I would like to explain about electromagnetic radiations, electromagnetic spectrum, types of spectrum and wave theory of radiations. Actually, you will get a doubt that this lesson is structure of atom. What is the relation between electromagnetic radiation spectrum and types of spectrum? What is the relation between the structure of atom and electromagnetic spectrum and wave theory? These are all concepts come under physics. But what is the need of teaching these concepts in atomic structure of atom? Actually, if we have taken one atom, that atom can absorb energy and release energy. If it releases energy in the form of light, that light analyzed to get a spectrum is known as atomic spectrum. Each atom will give a characteristic spectrum. That means by seeing that spectrum, we can say that this is because of that particular atom. That means a particular atom will have a particular spectrum. We can recognize by using spectrum, by seeing spectrum which is released from an atom, we can recognize a particular atom. Therefore, there is a relation between the spectrum and the atom. First of all, we should know about what is spectrum. Before that, I will tell you what is electromagnetic radiation. Electromagnetic radiations. Electromagnetic radiations means the radiations which have both electric field and magnetic field. Magnetic field. For example, all light radiations are electromagnetic radiations. Light radiations, TV rays, radio rays, cosmic rays, microwaves, all type of radiations. The light which is come from sunlight and tube light, and when a substance is burnt, the light which is coming from a candle, all these are considered as electromagnetic radiations. Why the name of electromagnetic radiation given to that? When an electric field, this is electric field, a substance with electric field, and which is kept under magnetic field, when this electric field rotates under magnetic field, some radiations are produced. These type of radiations are called electromagnetic radiations. Otherwise, if a magnetic field is taken, if it is rotated under electric field, this is electric field and magnetic field. If magnetic field is rotated under electric field, some radiations are evolved. Those radiations are called electromagnetic radiations. These electromagnetic radiations propagate, that means travels in wave form. That means electromagnetic radiations have wave nature.
Start.
According to Maxwell electromagnetic theory, he proposed that light is transmitted in the wave form. Light moves in wave form, and these waves associated with electric and magnetic field. Two fields are there, electric field and magnetic field. Consider this is electric field, this is magnetic field. These two are in perpendicular to each other. This will move in this way and this will move in this way. These two are perpendicular to each other and propagates in same direction. Electric field and magnetic field are perpendicular to each other, and these two propagates in the same direction and same velocity and same wavelength. All those are same only. That means wave nature is same only, but these two waves equally travels and perpendicular to each other. This is about Examples for electromagnetic radiations are X-rays, UV rays, infrared rays. UV rays means ultraviolet rays. Infrared rays, microwaves, visible light, radio waves, TV waves, radio waves FM and AM rays, TV waves, and etc. All these are considered as electromagnetic radiations.
So this is a typical electromagnetic wave as proposed by Maxwell. We've got three dimensions. We've got the x-axis that goes along in this direction. That's actually the direction of the electromagnetic wave. We've got the y-axis, and of course the third dimension is the z-axis. And of course the electric field is represented by red. So you can see that this red field is perpendicular to the x-axis, and it's of course it like a sine wave. It goes above and then it goes below. So we have crests and troughs. At the same time that the electric field is being generated, there's also a perpendicular magnetic field being generated in the blue. And those two are perpendicular, and they, as one gets bigger, the other one gets bigger. As one gets smaller, the other gets smaller. And so we have both perpendicular electric and magnetic fields, and notice that the z-axis, which carries the magnetic field, and the y-axis, which carries the electric field, are both perpendicular to the direction of propagation of the wave.
Start.
Electromagnetic spectrum. The meaning of electromagnetic spectrum means arrangement of all the electromagnetic radiations in the increasing order or increasing order of their wavelength or decreasing order of their frequency or energy is called electromagnetic spectrum. For example, if you have taken this example, electromagnetic spectrum, cosmic rays, its wavelength is about 10 to the power of minus 10 meters. Next, gamma rays. Gamma rays will have more wavelength than cosmic rays, and then X-rays will have more wavelength and less energy. UV rays. Next, visible region. This visible region, these rays only we can see. That means, for example, if you have taken white light, it contains 7 colors: violet, blue, indigo, yellow, orange, red. The wavelength of violet is 400 nanometers and the wavelength of red is 750 nanometers. Red will have more wavelength and less energy. Violet will have lesser wavelength and more energy. This is less energy and more wavelength. Next, infrared, microwaves, radio waves, FM and AM. These radiations radiation's wavelength is almost 10 to the power of 2 meters. That means the wavelength gradually increases from cosmic rays to radio waves. The increasing order of the pattern, increasing the arrangement of various electromagnetic radiations in the increasing order of their wavelengths is called electromagnetic spectrum.
Hi friends, are you ready to learn about colors of light, dispersion and spectrum in an exciting way? I have this light bulb here with me. It looks like a simple white bulb, but it's actually a magic bulb because I can change the color of this bulb using an app on my phone here. Let me show you how. So we have so many colors to choose from. For example, red light, pink, blue, green light, yellow. Wasn't that cool? Now I'm going to turn off all the lights in the room and we are going to use only this bulb. And we are going to look at these 3 blocks under different colors of light: red light, green light and blue light. And let's see what these blocks look like under colored light. And as usual, we'll finish off with our top 3 questions on this topic. So are you ready for our exciting experiment? Lights off, please. I'm now going to turn on our magic bulb. First, as you can see, the bulb is giving off white light. We have 3 blocks here: red, green and blue. Now I'm going to change the color of the bulb to red. Wow! Can you see the red block here? But we can't recognize the color of the other 2 blocks. They appear blackish. This is in fact the green block and this is the blue block. Now why is this happening? Because there's only red light here. And the red block is able to reflect the red light, so it's visible and appears red in color. But the green block absorbs all the red light and has no light to reflect, so it appears black. And same is the case with the blue block. It absorbs the red light and hence appears blackish in color. Now I'm going to change the color of the bulb to green. Under green light, can you see that the green block is visible, but the red block and the blue block appear blackish in color because the green block is reflecting all the green light, but the red block and the blue block absorb the green light, hence they appear blackish. Now I'm going to change the color of the bulb to blue. Now what do we have here under blue light? Can you see that the blue block is now visible, but the green and red block appear dark or black in color? Because the blue block is reflecting all of the blue light, but the green and red block are absorbing the blue light and hence they appear black in color. So what's our conclusion from the experiment? An object reflects light that matches the color of the object and it absorbs all other colors of light. Let's take an example. If we consider this red block here, it's reflecting red light. That's why it appears red to us, but it's absorbing all the other colors of light. Now when this red block was placed under different colored light, what did it look like? So under red color, it looked red in color. But when placed in blue and green light, it looked black because it was absorbing the green and blue light and it was not able to reflect any light because it can only reflect red light. That's why it appeared black. Similarly, the green block was visible under green light but appeared blackish under red and blue light. And same is the case for the blue block. So clearly we can see that these objects are reflecting light of their color, but they are absorbing all the other colors. When we look at these three blocks under white light, whether it's coming from this bulb or from the lights in this room, we can see all the three colors: red, green and blue. The red block is reflecting red light. The green block reflects green light and the blue block reflects blue light. So what does this tell us about white light? White light is actually not white. It at least contains these three colors: red, green and blue. But do you know how many colors there are actually in white light? That's right. The correct answer is white light contains millions and millions of colors. You may have heard of the 7 rainbow colors or the Vibgyor colors, but that's just a simplification. White light is made up of millions and millions of colors. Now an interesting question is, why does light have different colors? So what is the difference between red light, green light or blue light? Let's compare light with sound. Light and sound are both energies. They are waves. So when I play music in this keyboard, why do these sounds sound different? What's the difference between these sounds? That's right. These different sounds have different frequency. Similarly, different colors of light are light waves having different frequency. So the frequency of red light is different from green light, and that's different from blue light. And all these light waves of different frequencies make up white light. Now, can we separate the colors of white light? Absolutely. Let's take a look how. When you shine white light on a glass prism, as you can see, the glass prism splits the white light into its constituent colors. And this splitting of white light into its constituent colors is called dispersion of light. And the band of colors obtained by this dispersion of light is called spectrum. As we discussed, the spectrum band contains millions and millions of colors. But here we've just shown the 7 rainbow colors, the Vibgyor colors: violet, indigo, blue, green, yellow, orange and red just for simplicity. But actually there are millions and millions of colors there. Now can you think of examples where you've seen a spectrum, where you've seen the dispersion of light? One simple example is the beautiful rainbow, where you see the white sunlight splitting into the different colors. And another everyday life example is, if you look at the back of a CD or DVD, have you seen the different colors? It looks almost like a rainbow. That's your spectrum, and it's happening due to dispersion of light. As we learnt, white light is made of 7 different colors: violet, indigo, blue, green, yellow, orange, and red. This band of 7 colors is known as spectrum, and the splitting of white light into its constituent colors is known as dispersion of light. Now let's understand how our simple glass prism is able to split the white light into different colors. For this, we need the concept of refraction. Remember, refraction means bending of light. So let's start off by shining light of a single color, known as monochromatic light, let's say red light here, onto our glass prism. And as you can see, the light is traveling from air to glass, so there's a bending or refraction there. And once again there's a bending when light comes out of the prism, so from glass to air. And as you can see, the red light is bending towards the base of the prism here. Now let's replace the red light with white light. Again, for simplicity, we'll consider that white light is made up of the 7 Vibgyor colors. Now one important point to remember is that different colors of light have the same speed in air, approximately 3 into 10 to the power 8 meter per second. So all our 7 colors are traveling at the same speed in air. But the moment they hit the glass prism, the speed of the different colors changes in the glass prism. Red has the maximum speed and violet has the minimum speed. So because of the change in speed of the different colors, they bend at different angles in the glass prism. So as you can see, they split there. And then there is another refraction when these different colors are coming out from the glass to the air. So this is how the glass prism is able to split the white light into its constituent colors. So the important point to remember is all the colors have the same speed in air. Otherwise, we'll be seeing a rainbow right here in the air. But in glass or in any other medium, different colors have different speeds, and that's how they split up. As we saw, our glass prism splits the white light into 7 different colors. Now what do you think is going to happen if we place a second prism but it's inverted after the first one? That's right, we are going to get back white light again. So these 2 prisms are showing that white light contains 7 colors. The first one is splitting the white light into 7 colors, and the second prism recombines the 7 different colors back to white light. Let's place the concepts we have learned so far on our concept board.
Now I would like to explain about what is spectrum. When a light is passed through, for example, the light comes from candle, otherwise tube light or sunlight, any light, a thin beam of light is passed through the prism. Prism is a glass material. It is like this. When white light is passed through the prism, we know that the white light contains 7 colors. Vibgyor, violet, blue, indigo, green, red. Vibgyor, 7 colors. When this white light is passed through the prism, this yellow and green and red, all these are having different wavelengths. Different wavelengths will have different refractions. That means they bend when they touch that the surface of this one. They bend like this, and the more wavelength will bend like this, lesser wavelength will bend like this. That means they will bend, and these lines will be deflected. Deflected means separated, and these lines will come out in this way, and this pattern of light lines are collected on the screen. On the screen we'll get a spectrum, colored lines. This photographic plate, on this photographic plate, whatever we are getting, that is called spectrum. Spectrum. When a light, a thin beam of light, a small beam of light is passed through the prism, that means first this light has to be sent through a small hole split, and this light is allowed to fall on the lines, the pattern of lines formed on a photographic plate. These lines are called spectral lines. The total device is called spectroscopy. Here, the spectral lines which are formed here are the characteristics of atoms, molecules, or substances. Different substances will have different spectral lines. Different spectral lines are formed on the photographic plate. Now, spectral lines are spectrums are two types. One is spectrums are two types. First one is absorption spectrum. Second one is emission spectrum. Now I would like to explain about emission spectrum. Emission spectrum means, for example, some substance, that means any atom or molecule or anything has taken in the vessel in gaseous state. Gaseous substance is taken. This is a glass vessel. The glass vessel, in this glass vessel, some gaseous substance is taken. When it is heated, when it is highly heated or subjected to electric discharge, when electric arc is given, then these particles present in this vessel absorbs the energy. That heat energy is absorbed by these particles. This absorbed energy again loses in the form of light. These atoms loses in the form of light. That light sent through a small hole and allowed to fall on the prism, and will get a pattern of lines on the photographic plate. This is known as emission spectrum. That means these atoms or molecules or substance absorbs energy from the heat or from the source of heat or electrical energy, and whatever they have taken energy, again when they loses in the form of light, that light passed through the prism and will get some pattern of lines on the spectrum. This is known as emission spectrum. Generally, emission spectrum is formed on black photographic plate. This photographic plate color is black photographic plate, dark photographic plate with bright lines. I will show this one photographic plate. This photographic plate I will show it. White bright lines on dark photographic plate. If sodium is taken, we'll get two lines at yellow region, two lines, two different distinguished lines are formed on the photographic plate. This is called emission spectrum. Next, absorption spectrum. Absorption spectrum. Absorption spectrum means when a light, white light, a monochromatic beam of light, this contains all the radiations. That means VIBGYR, violet, blue, indigo, green, and all remaining electromagnetic radiations. It contains all electromagnetic radiations through a gas which is in a glass tube, through the glass tube. That means initially it will have all the radiations. When it is passed through a gaseous substance, gas is there in this vessel, then some of the radiations absorbed by this, some of the radiation, all radiations are there now. Here some of the radiations absorbed by these gases, the remaining light, that means the transmitted light, analyzed to get a spectrum, passed through a small hole and allowed to fall on the prism. You will get lines, pattern of lines. This is known as absorption spectrum. That means some lines, some light radiations absorbed by these gases, and the remaining light is the transmitted light, remaining light analyzed to spectrum, analyzed to get a spectrum is known as absorption spectrum. Absorption spectrum. Generally, absorption spectrum is formed on bright photographic plate with dark lines, dark blackish lines are formed on this photographic plate. That means at that place these lines are missing. That means on bright photographic plate will get dark lines at different regions. For example, if you have taken sodium vapor, when this light is passed to the sodium vapor, you will miss two lines at yellow region where they formed here. Two lines are formed in the same region. Two blackish lines are formed on the photographic plate. This is called absorption spectrum. Absorption spectrum. This is emission spectrum. Here you can see when gases are heated, they absorb energy, and that these gases again loses in the form of light. That is called emission spectrum. That means this light is due to emission of radiations from these atoms. Whereas here, this total radiations are passed through the gaseous substance. That means this light is passed like this. But here what is happening? Some of the radiations absorbed by this, the radiations of this light absorbed by this gaseous substance, the remaining light only will come out, and that light analyzed to spectrum is known as absorption spectrum. Absorption spectrum is formed on bright photographic plate with dark lines, and emission spectrum is formed at a dark photographic plate with black photographic plate with bright lines. Spectrum again can be classified into two types: continuous spectrum and discontinuous spectrum. What is continuous spectrum? Continuous spectrum means the light which is coming from sunlight or one substance is heated. That means when candle is burnt or some wood is burnt, then you will get a spectrum is known as continuous spectrum. Burning substances and the light radiations from sunlight, all these things can be considered as a continuous spectrum. In this continuous spectrum, if you see a rainbow, there is no sharp edges: violet, blue, indigo, green, orange, red. Here there is no sharp edge between violet and blue. These two merge together here. These two. Here also these two merge together. Therefore, here this type of spectrum is known as continuous spectrum. Continuous spectrum means what? There is no sharp edge between these two. But discontinuous spectrum again can be classified into two types: band spectrum and a line spectrum. Line spectrum is formed because of atoms. If atoms loses energy or gains energy, we'll get a line spectrum. Band spectrum is because of molecules, molecular spectrum, molecules. For example, some CO2 gas is heated, otherwise some H2O vapor is heated. That means these are all called molecules. Otherwise, line spectrum is because of atoms. Sodium vapors are heated, sodium atoms, sodium vapor, helium atoms, hydrogen atoms are heated, then we will get a line spectrum. Here the difference, band spectrum, here there is sharp edges. For example, if it is one color and another color, there is some gap between these two, and another color will be formed, another color will be formed. That means a closed bands thick bands are formed, light bands. This is one color, this is another color, this is another color. Bands are formed on photographic plate. But in light spectrum, a thin beam of lines are formed on photographic plate with a lot of gap. This is called line spectrum. Line spectrum is due to atoms, and band spectrum is due to molecules, and continuous spectrum is formed by burning of substance or the light radiations or tube light and etc. or the light radiation from tube light etc. can be considered as continuous spectrum. Continuous spectrum. You can see the line spectrum. What is that? Sodium vapor lights in the street lights. In the street lights, you can see the light of the street lights is yellow color. The yellow color because of that sodium vapor. Sodium vapor will have a particular line at the yellow region. This is about continuous spectrum and discontinuous spectrum.
Here you can see three type of spectrums. First one is continuous spectrum. Here clearly you can observe the colors are merged each other. There is no sharp boundaries for each color. In second one is absorption spectrum. In that absorption spectrum, here dark lines, black lines are formed on the bright photographic plate. Same above continuous spectrum, whatever it is there, on that dark lines are formed. But in emission spectrum, third one, in black photographic plate, dark photographic plate, we got bright lines. You can see green line, red line and violet line on the screen. That means here emission spectrum is formed on black photographic plate, dark photographic plate with bright lines. Absorption spectrum is formed dark lines with on bright photographic plate. Here you can see the emission and absorption spectrum of sodium. First one is emission spectrum of sodium. On dark photographic plate, two yellow colored lines are formed. Two yellow colored lines are formed. But in second case, on bright photographic plate, two dark lines are formed at yellow region. You can see background at yellow region, two dark lines, two black lines are formed. That means the emission spectrum of sodium and absorption spectrum of sodium formed at same region. The difference is the emission spectrum is formed on dark photographic plate with bright lines, and absorption spectrum is formed dark lines on bright photographic plate.